So part A here asks us to calculate the cosecant of theta, secant of theta, and the cotangent of theta for these four triangles. So for part A, triangle number I, let's calculate what the cosecant theta is. Now remember, cosecant theta is the reciprocal of sine of theta. And sine of theta, we know, using the SOHCAHTOA, is the ratio of the opposite side of the triangle divided by its hypotenuse. So if I look at the first triangle here, the opposite side is 6, hypotenuse is equal to 10, and the adjacent is equal to 8. While I'm at it, I'm going to just label all the other triangles as well. So for the second triangle here, the hypotenuse is 12. Given that theta is here, this will be the adjacent, and this side will be the opposite. Triangle number 3, theta is here, so 2 is the adjacent, 3.6 is the hypotenuse, and the opposite is 3. And triangle number 4, theta is here, hypotenuse is 17, opposite is 8, and the adjacent is 15. So back to our first triangle here, opposite over hypotenuse. Let me get back to the black pen here. 1 over opposite over hypotenuse will simply be the hypotenuse over the opposite. Hypotenuse of the first triangle is 10, opposite side is equal to 6. Reduce it, and we get 5 over 3. The secant theta of this first triangle, once again, secant theta is a reciprocal of cos of theta, and cos of theta is equal to the ratio of the opposite, the adjacent divided by the hypotenuse, which is equal to the hypotenuse divided by the adjacent. The hypotenuse is equal to 10, the adjacent is equal to 6, therefore, the adjacent is equal to 8. Divide both sides, or the numerator and the denominator, by 2 to get 5 over 4. The cotangent of theta is the reciprocal of tangent of theta. And tangent of theta is equal to the opposite over the adjacent, SOHCAHTOA, which is equal to the adjacent over the opposite. Adjacent side is equal to 8, opposite is equal to 6, and we are left with 4 over 3. Now let's do the same thing for the second triangle at the bottom here. The cosecant theta, as deduced above, is the ratio of the hypotenuse divided by the opposite side. Hypotenuse is equal to 12, and the opposite side is equal to 8.5. The secant of theta is equal to, as once again deduced in part I, the hypotenuse divided by the adjacent. The hypotenuse is equal to 12, the adjacent is equal to 8.5. And finally, the cotangent of theta is equal to the adjacent over the opposite. And adjacent over opposite is equal to 8.5 over 8.5, which is equal to 1. Triangle number 3. The cosecant of theta, once again, is hypotenuse over the opposite side, which is 3.6 divided by 3.0. The secant of theta is hypotenuse over adjacent, which is 3.6 divided by 2.0. That simplifies nicely into 1.8. And finally, the cotangent of theta is equal to the adjacent over the opposite. which will be 2 over 3. And the fourth triangle, the cosecant of theta is hypotenuse over opposite, 17 over 8. The secant of theta is hypotenuse over the adjacent, which is 17 over 15. And the cotangent of theta will be the adjacent over the opposite, which is 15 over 8. So there we have it. That's part A. We have computed the reciprocal trigonometric ratios for all 4 of these triangles.